Hi class, this is from the Stat 202 manual, Learning Outcome 5, Learning Step 6, Hypothesis Test for Differences of Proportions. So, this is sort of, I have a few more videos left that I'm going to record for this class, and I'm going to try to get those up right away. This is going to be about testing, or doing a hypothesis test, when instead of a mean or a difference of mean or a population proportion, you have two different population proportions and you want to look at the differences between them, or test for if there's a difference between those two populations. So let's take a read. To test the effectiveness of a vaccine, a group of 500 individuals was inoculated while another group of 500 was given a placebo. 8 of the vaccinated individuals and 15 of the placebo became ill. Is this sufficient to suggest that the vaccine is effective in reducing the proportion of sick individuals? So when I look at this question, you're thinking proportion. It's going to be one of the proportion questions when you see proportion. And then the fact that I have two different groups involved and each of them has some number of vaccinated individuals who became ill or placebo individuals who became ill, this tells me I probably have two different proportions, because I'm going to have 8 over 500 and 15 over 500, and it suggests we have a difference of proportions. Now, this is the formula you want to use when worried about difference of proportions. Notice we don't put t there. Certainly you could be concerned with you could do a t-test for this, but for the most part in this class in Stat 202 we focus on the z-test. So those of you who aren't in Stat 202, you're going to have to look elsewhere if you're looking for a t-test. Okay, so let's set this up. So again, we got to go through all the steps of hypothesis testing: state the null hypothesis, state the alternative hypothesis, determine the rejection region, calculate the test statistic, state the conclusion, and interpret. So number one, well, you know what? Why don't we figure out which values we have first? So there's a few different things going on here, and we have to make sure that we have the correct values. So I just want to try to walk through these. So P1 hat, this is the sample proportion for the first group. Now the first group we're just going to assume, just because of the way that the question's written, these are the vaccinated individuals. So P1 is going to be 8 over 500. Okay, and you can see where I'm getting that from. There's 500 individuals inoculated, and then 8 of those individuals got ill. So 8 over 500. So this is equal to 0.016. And additionally, we also have P2 hat. So sample proportion. This is going to be, 15 individuals became ill when they were given a placebo. And we're still looking to see if that vaccination had an effect. So 15 out of 500 is 0.03. Okay. Now you'll notice there's N1 and N2. N1 is equal to 500, and actually conveniently enough, N2 is also equal to 500, because there was 500 individuals inoculated and 500 given a placebo. But then we also have these P bar. You see they got this little bar over top of the P and a little bar over top of the Q. Well, this is the formula for P bar, and this is the formula for Q bar. So just like we've been doing before when we had to deal with just simply hypothesis tests of proportions, Q was always 1 minus P. So let's just figure out P bar. So P bar is equal to x1 plus x2 over n1 plus n2. So where do we get these x's from? So x1 is actually equal to 8. This is sort of implicit in what I wrote here. I didn't make it explicit, but and x2 is actually equal to 15, because that's the number of people, or the number of data points in your sample, if you want to put it that way, that had the trait you're interested in. So let's figure this out. We have 8 plus 15 divided by n1 plus n2, 500 plus 500. So it's going to be 23 over 1,000. Okay. So this is going to be, so we get 0.023. Okay. All right, so let's work through it. Let's do the hypothesis test. Let's get into it. 1, we state the null hypothesis. So H naught, anytime you're working with these difference of proportions, the H naught is always going to be P1 minus P2 is equal to 0. Okay, so we're testing if there's a difference between the proportions, and that's always going to be the case. H1, the alternative hypothesis, well, let's look at the question and ask what it's asking. It's asking, was the vaccine effective in reducing the proportion of sick individuals? Okay, so if P1, if the first is your vaccinated individuals and P2 is our placebo individuals, for the vaccination to do anything, we'd need this number to be smaller than this number, right? In other words, we need P1 to be less than P2. And that's because, again, if we want the vaccination to have had an effect, the proportion of people who got sick after getting vaccinated should be lower than the proportion of people who got sick after receiving the placebo. So then when we solve it, this is going to be less than 0. So this is 2. 3, we have to decide first of all if this is 1 or 2-tailed. Well, because that's a simple less than sign, this is going to be a 1-tailed test. Okay, and again, this always depends. Like this step always just depends on what this sign is. That's always how you pick it. Once you pick this, once you know what this is, it requires no other thought. You always have to make sure that if this is a less than or a greater than sign, it's a 1-tailed test. If it's an equal sign or a not equal to sign, it's a 2-tailed test. So let's get to it. The first thing we have to do is we have to figure out that critical value. Okay. Determine the rejection region. So when I build this normal distribution, it's a negative, so the rejection region, it's 1-tailed, and it's negative, so the rejection region is going to live down here. And what I have to do is find that Z alpha value. So if this, and remember, in all of these tests, I've been using alpha equals 0.05. So this is going to be 0.05, and that means that this region in here, we'll just use purple just for the fun of it, this region in here should be 0.45. Okay, so then I pull out the sheet, see if I can reverse engineer a Z value. What do we get here? 0.45 is right here on this little star, and it gives me a Z score of 1.645. So Z alpha is equal to negative 1.645. It's a negative number, right? It's below 0. From there, put down 4. What do we have here? So for we have to calculate the test statistic. In this case, I'm going to get out my formula sheet. Notice here's my test statistic. And this is why I figured out all these numbers. This is the test statistic right here. So it's Z equals P1 hat minus P2 hat over, it's a pretty big expression on the bottom, the square root of P bar Q bar. By the way, let's just compute Q bar just for the fun of it too. Q bar is equal to 1 minus P bar. Okay, P bar is 0.023, so let's just make sure we get this right. 1 minus 0.023, and we get Q bar is going to be 0.977. Okay, and then in brackets here, still all underneath the square root sign, we have 1 over N1 plus 1 over N2. Okay, so let's plug our values in. We have 0.016 minus 0.03. Right, we plugged in P1 and P2. Then at the bottom, and just to make a point, it can often be really helpful when you're looking at just a straight word problem with no variables in it at all, or no statistics in it, to just take those numbers and write them down in sort of a nice format up at the top. I'll certainly give you partial marks if you're in my class and you happen to be like, a small amount of partial marks, because I like to see that you do your work. But yeah, you just write them at the top. It can really be helpful to be able to see what each of the values equal to, so that the amount of mental effort you need to do later is a little bit reduced. So plugging the numbers in, 0.023 for p bar, 0.977 over here, 1 over n1, which is 500, plus 1 over 500. Okay, and that's still all under the square root sign. So you have to square root all that at the end, and I'll walk through that. So okay. Hit the square root button. So I get, on the bottom, 0.00948 1, and then on the top 0.016 minus 0.03, so I have negative 0.014 on the top, and we're going to divide that out by 0.009481. What do we get? We get that this is equal to negative 1.48. So unfortunately, negative 1.48 is actually not less than the value that we're looking for. So remember, this z was equal to negative 1.645. And so then this negative 1.48 is going to live right here. So that's negative 1.48. And you know what? That's not in the rejection region. So our conclusion, 5, is we fail to reject the null hypothesis. And 6, there is insufficient evidence that the vaccine will reduce the proportion of sick individuals. Okay. All right. Thanks very much. See ya.